Question number 13. Suppose that each children born to a couple is equally likely to be a boy or girl. Independently of sex distribution of the other children in the family, for a couple having five children, compute the probabilities of the following events. Okay, so let's say we have 5 slots. The youngest one can be boy or girl. This one can be boy or girl. Same old for all slots. So we can just say we have 2 options for each of them. So in order to calculate how many outcomes we have in the sample space, we just need to multiply them. So we can just write 2 to the power of 5, which is 32. We have 32 equally likely outcomes. Okay. So let's calculate A. All children are of the same sex. This is simple. So simply we know the sequences. Like one event will be, let's write it like this. The first event will be boy, 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 and girl, 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 girl. In each slot we have either have boys or girls. Since we have 32 in total, the probability will be 1/16 for the section A. In the section B, the 3 eldest are boys and the others girls. So we know the exact sequence in this section. So it's simpler. The first 2 is girls and the last 3 is boys. Of course, the probability is going to be 1 divided by 32. Let's solve part C. Exactly 3 are boys. So out of 5 slots, we need to choose 3 for the boys. And we already know the probability of having a boy is 0.5. We need to take the power of 3 because we have 3 boys. And we know the probability of having a girl is 0.5. And we need to take the power of 2 because we have 2 girls to have exactly 3 boys. Okay, so we had 5 slots and selected 3 of them for the boys. And probability of having a boy is 3. We take the power of 3. And having a probability of having a girl is 0.5. And we take the power of 2 because we have 2 girls. So this is the probability of having exactly 3 boys. Then the answer is 5 divided by 16. Let's go to section D. So in section D it says the 2 oldest are girls. So in this one we sort of fixed the last 2. So we already know they are girls. These ones are fixed. We need to make some calculations related to the first 3 slots. So the first one we have 2, for the other one we have 2, and the last one we have 2 options. So overall we have 8 options. So that's why we can just say 8 divided by 32 many options. Actually 8 options that satisfies this constraint. 2 oldest are girls, and overall we already know we have 32 many options, and then we can just divide them to find this probability of having 2 oldest are as girls. let's go to the section E. It says there is at least one girl. In that kind of questions, instead of calculating all of the combinations that have a one girl inside, we can just calculate the combination that have no girl. So it means instead of calculating probability of there is at least one girl, we can just calculate the probability of having no girl and subtract it from 1. So there is just one instance that we have no girl, which is all of them is boys, and the probability of this one will be 1 divided by 32, and that's why this will be 31 over 32.